Okay, hello, my name is Ethan Hazlett, and alongside Jake Miller, this is our FIPT 104 case study project. We chose to do ours on the Texas restaurant fire and collapse. Without further ado, here we go. So, this is just a picture, probably at the peak of the fire. Not sure at what point all the action has completed, but this incident occurred on February 14th, the year 2000. Here is a diagram of the building layout. So, most likely, just from looking at it and inferring from the report, it was a type 3 building, so ordinary construction. There's multiple points of ingress and egress. You'll see it was a restaurant. So, things to consider as far as the building construction: walls, usually made of non combustible materials, reinforced masonry, but the roof is usually lightweight or wood, and that is very flammable. And these are one of the things that we'll discuss later in the case study that contributed to two line of duty deaths. Strengths with type 3 construction: exterior walls are able to stand even if the floors or the roof collapses. They're very strong. The weaknesses is that sometimes they have attics or drop ceilings, much like this restaurant ended up having, that we figured out in the report. And that allows fire to spread rapidly and cause what later became a roof collapse. So, what exactly happened? The fire took place in February of 2000. It started in the back office. So, if we go back here, where is the back office? Most likely back here. Started in the back office, and then it extended into the ceiling. So, as we talked before, those void spaces which allow fire to rapidly grow and hit the lightwood truss system, which we'll discuss is one of the many reasons of why the roof collapsed. This led to two firefighters dying on this incident. So they were off of engine 76. They were the first due engine on scene, and they were assigned to make an interior attack. And while they were making their exit, the roof collapsed in the middle of the restaurant. And although you could see that there were multiple points of egress, it blocked both of them. One was found near an HVAC unit, and the other was 6 feet from the rear exit door, and they were all tangled in wires. Very sad occurrence, but there's a lot of things we can learn from this incident. It was eventually declared to be arson by the city arson bureau. So the specs, flaws, design factors that contributed to the collapse. So the roof was made with a lightweight truss system, and the exposure to intense heat and fire. What happens to these gusset plates on these lightweight truss systems is that they fail due to heat, and then when one truss system fails, it then puts stress on all the other ones, which then just leads to roof collapse. This in the NIOSH report from the incident posted by the CDC, it says fire engineering calculations show that the lightweight truss rafters may expected to collapse in as soon as 10 minutes in a fully developed fire. So if we think back to that original picture that we had from the fully involved structure fire, as soon as 10 minutes, it depends on when fire crews show up, when the closest engine is, but 10 minutes is very fast in an incident. And keeping this in mind for firefighting operations, as well as the knowledge of building construction we have as people into the fire service. The advantage that this type of truss system distributes the load of the roof across the whole system, so it's allowed to hold more weight. We'll see that later on. We'll discuss what the actual fuel load was on top of the roof. And like I mentioned before, that if one truss system fails, it puts the stress on the rest of them, which later caused all of them to fail. Like we talked, the metal gusset plates. So when they're heated, it destroys the wood fibers. And these are the things that are really holding them together. So here we have some pictures of truss systems, non-enclosed. Here we have the gusset plates right here. And all it takes is for one of them to fail, and it puts stress on all the rest of them. So in addition, the restaurant had a parapet wall with a total of 5 HVAC systems on top of the roof. So there were 3 10-ton units, 2 5-ton units, and just alone from the HVAC systems, there were 80,000 pounds of fuel load on the restaurant's roof, which is extremely dangerous to consider from a firefighting standpoint. And for the sake of a parapet wall, making sure you have that correct scene size up to know what you're getting yourself into, and understanding that parapet walls are concealing a lot, considering that for a restaurant. Um, and then coming back here, talking about the suspended ceiling. So the restaurant inside the building, it was suspended about a foot below the truss system. And this void space was really where the fire was able to rapidly grow and be undetected. So ultimately contributing to 2 line of duty deaths, causing roof collapse. It the the truss system being affected by this was ultimately the main problem of why the roof collapse occurred. So that concludes our screencast, our presentation. The main sources we used were the NIOSH fire report that occurred after the incident in February in the year 2000, and then in addition our textbook. So ISTA building construction related to the fire service 4th edition. Thank you for listening, and have a good day.